Hi, Math A. Good to see you again. This is lesson 3-4, inputs and outputs of functions. So the notation f of x is sometimes used to show that we are looking at a function. Now, f of x is just the y value. So f of x is the same thing as the y value. It's just a notation that's there to tell us, hey guys, you're looking at a function. Remember, functions are when the inputs have only one output. They're very predictable, they're consistent, we like to use them. All right, so f of x is just another way to say y and to at the same time say, hey, we're looking at a function. All right, f of x means the output, the y value, is a function or a result of whatever you plugged in for x. So that means that f of x, the y value, depends on whatever you plugged in for the x value. That's what a function means. All right, so we're going to look at going ahead and graphing a function by making a table of points here. So my input is -4. My output would be y, or f of x. So I would plug in -4 here. 2 times -4 is -8, and then -8 minus 1 is -9. 2 times -1 is -2. -2 minus 1 is -3. If I plug in 0, 2 times 0 is 0. 0 minus 1 is -1. 2 times 3 is 6. 6 minus 1 is 5. 2 times 5 is 10. 10 minus 1 is 9. All right, we got a bunch of points there. Let's go ahead and graph them and see what we get. So I've got -4, -9. So -4, -9. There's my first point. Next point is -1, -3. There's my next point. 0, -1, right here. 3, 5. 5, 9. Now, hopefully you realized that this was going to give you a line. Why? Because it's in the form y equals mx plus b that we did in the last unit. So this is a linear equation because it's in the form of y equals mx plus b. We have created a line using our inputs and outputs for the function. So this would pass the vertical line test. We could make any vertical line and it would not pass through it. That's why it says f of x, because it's a function. This is going to pass the vertical line test. All right, here we've got a nonlinear function. I can tell it's a nonlinear function because it's not in the form of y equals mx plus b. This one has x squared. Linear functions do not have x squared. They have x to the first. So this is going to make a different type of graph. We're going to call this a quadratic graph. So it's going to make a kind of like a U shape. So if I plug in -2, remember, if you square a negative, it becomes positive. Because if I plug in -2, that's -2 times -2, 4. 4 minus 1 is 3. If I plug in -1, -1 times -1 is 1. 1 minus 1 is 0. 0 times 0 is 0, minus 1 is -1. 1 times 1 is 1, minus 1 is 0. 2 times 2 is 4, 4 minus 1 is 3. All right, so this is going to make a nonlinear graph. -2, 3 is right here. Next point, -1, 0, right here. Next point, 0, -1, oh, right there. Next point, 0, 1, 0. Can't think. Last point, 2, 3. So this makes kind of like a U shape. We call these parabolas. You'll do them quite a bit more when you get to high school. So there's a parabola. Which points are solutions for both functions? So right here, they both share this point. That is the point 0, -1. We have another solution over here. They both share the solution of an input of 2 and an output of 3. So they share input 2, output 3. Even though we didn't plug in 2, 3 over here, it's on a line, so it will eventually go through there. We could even plug in 2. 2 times 2 is 4. 4 minus 1 is 3. All right, so there we've got a linear function and a nonlinear function. All right, so we're going to apply these function rules and just get some inputs and outputs and solutions. Okay, so first one, y equals 5x minus 4. Okay, so the function rule is I'm supposed to take the input, x, multiply it by 5, then subtract 4. That's the rule of the function. So I would do 5 times -2 minus 4. So that would be, what, -10 minus 4? So my output, when I plug in -2, should be -14. Input -2, output -14. That is a solution, -2, -14. And then we're going to do it with all the other points. 5 times -1 minus 4. That would be -5 minus 4, -9. So another solution would be -1, -9. Plug in 0. 5 times 0 minus 4. That would be 0 minus 4, which is -4. So we have an input of 0, output of -4. That is a solution to the equation that we had up there. Next one, 5 times 1 minus 4. That's 5 minus 4, which would be 1. So I have a solution of 1, 1. Last one, 5 times 2, because my rule says I take 5 and multiply it by the input, minus 4. So that's 10 minus 4, which would be 6. So I've got 1 or 2, 6. All right, is this function linear? Well, there's a couple things that we could do. We could check to see the rate of change, or we could just look at the equation here. Uh-oh, my battery's running low. Got to get through this one fast. All right, so we should, you know what? Let me go get my power cord just a second. I'm going to pause. All right, back again, jiggity jig. All right, so for this one, this is in the form of y equals mx plus b. So yeah, that's going to be a linear function. Now we could have looked for a rate of change. As the x was increasing by 1, the y was increasing by 5 each time. So that's a constant rate of change. Okay, next one, f of x equals x squared plus 6. So I just used f of x instead of y. They're the same thing. It's just indicating to us that, yes, we are looking at a function. So we're going to use the function rule x squared plus 6. This means we take our input and we square it, or multiply it by itself, and then add 6 to it. So my input of -2, I'm going to square it and add 6. So that would be 4 plus 6, which is 10 as an output. Input 2, output 10. Sorry, that was -2. -2. So there's one of my solutions. I input -2, I output 10. Next one, I input -1, square it, add 6, because that's the rule. I get 1 plus 6, which is 7. So that would be the function -1, 7, or the solution -1, 7. I'm going to plug in 0. 0 squared plus 6. That's the function rule. I square the input and then add 6. So 0 plus 6 is 6. We get 0, 6. Notice I can now tell that this is not linear because I'm always increasing by 1 over here, but here I decreased by 3, then I decreased by 1. That's not a constant rate of change. So this is definitely not going to be a linear function. We'll finish plugging everything in. We get 1 squared plus 6. That's 1 plus 6, which is 7. So that's the point 1, 7. And I can plug in 2. 2 squared plus 6 is 4 plus 6, which is 10. So that's the output or the solution, 2, 10. All right, so we put in our input, applied it to the function rule, got our output. And then that input and output together is a solution of the function. Next one, absolute value. You probably did this in 7th grade. Maybe you don't remember it, but you did. Remember, absolute value is how far a number is from 0. So like when we're saying how far we are from something, we never say positive or negative. So like if I'm 3 miles away from my house north, 3 miles south of my house, I'd still be 3 miles away. I wouldn't do I'm negative 3 miles away or something like that, right? So it's just always going to be a positive number. Okay, so this is going to give us the absolute value that we have to do first. So I'm going to do absolute value of -2 plus 7. So remember, the absolute value of a negative number is positive. So that's 2 plus 7, which is 9. So that's the point -2, comma 9. If I plug in -1 plus 7, so the absolute value of -1 is 1. 1 plus 7 is 8. So that's the point -1, 8. So it looks like I'm decreasing by 1. Everything's good so far. If I plug in 0 plus 7, I get 0 plus 7, which is 7. So I'm still decreasing by 1. All right, so it's looking linear right now. So I get 0, comma 7. Let's plug in 1. 1 plus 7, so that's 1 plus 7, which would be 8. Wait a minute. I was going down by 1. Now I'm going up by 1. Negative rate of change. Now it's a positive rate of change. This is not linear. It looked like it at first until we got to these numbers over here. So this would be 1, comma 8. Over here, we're going to have an input of 2 plus 7, which is going to be 2 plus 7, 9. So our last point is 2, comma 9. So it looked like it might be linear until we got to this point right here, because we were subtracting 1 each time, and then all of a sudden we started adding 1 each time. In fact, these types of equations give us V-shapes, which have components to them which are linear, but overall it's not one straight line. Okay, last one. So this is not a linear function. Last one, y equals mx plus b. I can already tell, yes, that is a linear function. It's going to work. So let's plug it in. -2 times -2 plus 3. So my function rule says multiply the input by -2, then add 3 to it. So that's 4 plus 3, which is 7. So my input is -2, output 7. Let's plug in -1. So -2 times -1 plus 3, that would be 2 plus 3, 5. So my next point is -1, comma 5. Let's plug in 0. -2 times 0 plus 3, which would be 0 plus 3, 3. That's the point, 0, comma 3. Let's plug in the point 1. We get -2 plus 3, which is 1. That's 1, comma 1. Last one, let's plug in 2. -2 times 2 plus 3. That'd be -4 plus 3, -1. Down by 2, down by 2, down by 2, down by 2. Constant rate of change. So yes, this one would be a linear function. My last point would be 2, -1. Now we already knew it was a linear function because up here, it's in the form of y equals mx plus b. All right, guys, that's all I got. Math hard? I will see you guys later. Bye-bye.